Hello everyone, let's discuss 10 outstanding problem based on entropy. First, which of the following correctly represents the trend of entropy across the phases of matter? So this is very simple. We know that because entropy increases from solid to liquid to gas, and the gas have the most molecular disorder. We can say the gas has the maximum molecular disorder. Then it will be liquid and solid, so the correct answer should be B. Let's see the next one. Entropy of gas increases logarithmic with which of the following? Okay, so if you talk about the gas, like suppose if it is any gases with various molecular weight, if you go on increasing molecular weight, actually the entropy will increase logarithmically. So the correct answer should be what? Mass, that is molecular weight. So as the mass of the gas will increase, okay, entropy will increase logarithmically. Coming to next, which are the lowest entropy among these, all having same mass? So if you see, neon is monatomic, right? And neon has, this has no rotational or vibrational degree of freedom. It has no rotational, no vibrational degree of freedom. Okay, so in this case what will happen, neon will have less heat capacity, right? Okay, and HF and water, they will having what? More heat capacity, more heat capacity, and due to that it will be having higher entropy. So lowest entropy will be of neon. Next, water has higher entropy than HF. This is due to what? So if you see, HF is a linear molecule, it's a linear and diatomic, but water is what? Bent. It is polyatomic and non-linear and bent. Due to that, water will have one additional degree of freedom, and hence it will have more heat capacity, right? So water will have total 3 rotational degree of freedom, but HF has only 2. Okay, rotational degree of freedom is 3, and here rotational degree of freedom is only 2. So you can say water has higher entropy. So correct answer should be B. Among N2CO, ammonia and methane, which is expected to have highest entropy? Okay, so basically if the molecules are of comparable molecular weight, then we have to see the symmetry. Okay, higher symmetry in the molecule will lead to lower entropy. Okay, so symmetry is what? Inversely proportional to entropy. So least symmetrical we can say is ammonia. Okay, it's polyatomic also. It has more degree of freedom as well as it is least symmetrical. So it will have higher entropy. So correct answer should be C. Next is, which solid would have the lowest entropy at room temperature? Now, entropy basically, if you go to uh, different, materials, we have to decide with the cohesive energy or the lattice energy basically. So if you just see diamond, it has the highest cohesive energy. It's the strong bonding and it's tightly bound lattice, and due to that it will have lower entropy. Next is, why does silicon have higher entropy than diamond? So it is very simple, because silicon has lower cohesive energy, so it will be easy to vibrate. Okay, so it will having vibrational frequency will be also lower, and due to that it will be having what? More entropy, more randomness. Now, a solid made of three simple units will have entropy approximately three times, actually three times a simple solid, right? The simple units will have entropy actually n times of one simple unit basically. Next, what is the nature of binding forces in solid with a single complex unit and high entropy? Okay, so if it will be high entropy, it will not be ionic bonding, it will be simply van der Waals forces, because that is the weakest force, right? It will have the lowest cohesive energy, and due to that it will be having the higher entropy. Next is, why do crystal with complex unit have higher entropy? If the unit is complex basically, then what we can happen, there will be more way to store energy, or we can say it will have additional degree of freedom, more complex, more degree of freedom. So it will be more ways to store energy, and it will have higher heat capacity, and you know that heat capacity and entropy are directly proportional, so it will be higher entropy. So basically the best option will be what? C. They will have higher degree of freedom, more additional degree of freedom, leading to higher heat capacity, more randomness, and more entropy. So that's all about the 10 outstanding problems of entropy that will be very helpful for you in J and J Advanced. Thank you.